Hello, I'm Richard with EV4U Custom Conversions. And today we're going to talk about EV conversion basics. Kind of go back to the beginning and talk about the basics of a conversion, the components. So let me first start by saying if you're into good-looking people on YouTube, if you're into fancy graphics, maybe some drone shots, fancy editing, you're on the wrong channel. It's just an old guy in a warehouse sharing some information. So if that's what you're interested in, let's jump right in. So there's 5 basic components. Actually, there's 6. And we'll talk about those. Maybe you can even say 7. But we're going to talk in depth, or not in depth, but we're going to talk mostly focus on 5. And the 5 are your battery pack, your traction battery that provides the energy for the propulsion. We're going to talk about the charger. Most conversions, as is most EVs in general, have an onboard traction pack charger. We're going to talk about the controller, the motor, and a DC to DC converter. Now, most of these items you've probably heard of. You may not have heard of the DC to DC converter, but they all have it, and we'll talk about it. Now, I said that's 5. I told you there's 6. You can even say 7. And that is, in a conversion, we're commonly going to have an adapter that adapts the motor to the bell housing of the transmission. So that'd be 6 items. And I tend to group the adapter and coupler together. The coupler is what couples the motor shaft to the flywheel. The clutch is mounted on the flywheel and just goes to the intake shaft of the transmission, so forth. So 5 main components we're going to talk about today. And all conversions have these 5 components, and all EVs have these 5 components. So just numbered them for reference for you: 1, 2, 3, 4, 5. And we can see them here: 1, 2, 3, 4, and 5. But let's start at the beginning. We have 2 systems in a conversion. You have 2 systems in an electric car. You have the 12 volts system, and you have the traction pack system. The traction pack voltage in a conversion will typically be 120 volts on up, and in most OEM EVs, it's 300 to 400 volts. So we'll start with the 12 volts. The 12 volt system, of course, as far as the conversion is concerned, is kind of separate from the car. In other words, you have the car's chassis wiring. You have a 12 volt system that operates the horn, the lights, the wipers, your stereo, all of your air conditioning, all your normal stuff. Well, maybe not the air conditioning on an EV, part of the air conditioning, the blower. But that's separate. We're not really concerned about that because we're only concerned about that 12 volt battery, that 12 volt energy source. And then we're concerned about the ignition, because you're going to have circuits in an EV that are on all the time, just like on the chassis. Those are unswitched 12 volt circuits. And then you have switched 12 volt circuits, circuits that come on with the ignition. Okay? And so in our little flow chart here, we're going to start with our 12 volt battery. And we're going to go through the ignition, because that's what's going to turn on our controller. The controller's not on all the time. It comes on with the ignition. So we have our 12 volt battery. So that 12 volts is switched by the ignition, which then turns on our controller. Now, a separate system is the traction pack system. That's the system that provides the propulsion, what gets the wheels turning. And that consists of our traction pack, your battery pack, which sends energy to the controller, and the controller sends energy to the motor, controlled energy, so you can vary your speed. Okay? And so that's, 1, 2, or 1, 3, and 4. Number 2 here is the charger. That's how we replenish the energy that we use from the battery pack to power the motor. So the charger recharges the traction pack and the cycle continues. But to get power to our traction pack, or to the charger, we have a charge port, and typically that'd be what we call a J1772. It's the level 2 standard in the US, which is 220 volts, 30 amps. There's also adapters you can use so you can charge off 110, and different vehicles have different fast charge capabilities, and there's several of those. Of course, Tesla has their own. Nissan uses another one, and the bulk of everybody else uses another. Okay, the SAE combo. So you've got a charge port, and then you have the charge station, technically called an EVSE, electric vehicle supply equipment. That's what then plugs into your charge port, which provides power for the charger, which then charges your traction pack. And the EVSE is going to get power either from solar or the grid. So that's everything in a nutshell, and very simplified. But let's add a little bit more, because we can still stay in this very basic stage, but we can provide a few more insights to this picture. So now let's fill in a few blanks. Now, I didn't talk about the DC-DC converter last time, in that last little explanation, but I will now. But we're going to start back with the 12-volt battery. Remember before we had our 12-volt supply, we went through the ignition switch, and went to the controller. Very simplified. Well, we're keeping it simple, but we've added a few things that I think every conversion should have. Okay, one is a safety interlock. And again, these are things that if you bought a factory-produced EV, they would have these things. And what I mean by a safety interlock, what it does is it disables the vehicle when you have it plugged in. So whether you're charging or not, it doesn't matter, because you could have been charging it, charging's complete. As long as it's plugged in, the vehicle's disabled, so you can't drive away with the cord, okay? And so if the ignition's off, of course nothing's going to happen. If the ignition's on, we're going to have 12 volts go to our safety interlock. If the vehicle's plugged in, that's as far as it goes. But it's not plugged in, then it goes to an inertia switch. An inertia switch is in most modern vehicles, and most people aren't aware of it. It's typically in a spot that you don't see it, under the dash, that kind of thing. But what an inertia switch does is it shuts off the power to the fuel pump. So most modern cars have an electric fuel pump, and the fuel system is pressurized. And in an accident, if you sever the fuel line and the ignition's on, that fuel pump's going to want to maintain pressure. But if the fuel line's severed, it's just going to keep on pumping. You're going to be pumping flammable gasoline or diesel all over the roadway. So they have an inertia switch, And it's basically a normally closed switch, but in an accident, boom, that switch opens up, disrupting the 12 volts going to the fuel pump and shuts the fuel pump off. Well, we do the same thing. So if you're in an accident, boom, it shuts off power to the controller and the wheels won't be spinning in case you're pinned in the car and your foot's pinned on the throttle or whatever. It's just a safety feature for you and first responders. So that's the inertia switch. And then the next one would be a low voltage cutoff. So that's to protect your battery pack from over discharge. So whatever that threshold would be on your conversion, you would have it so that when you reach that threshold, it would shut the power off so that you don't over discharge that battery pack. So there's 3 layers of protection there, and you can add more, but those are the basics. So this is the 12 volts going into the controller, KSI, key switch input or interface. Now some controllers use traction pack voltage for that KSI signal, and in that case, that relay that takes that traction pack voltage and applies it to the KSI, that's going to be operated by 12 volts. And so that 12 volt signal will just interrupt or energize that relay. So that's the 12 volt, the low voltage setup. Now let's look at what we added to the traction pack portion. So what we've done, instead of just going from the traction pack directly to our controller, and you've got power there all the time, we've added what we call the main disconnect. And that's going to be somewhere close to the most positive point on your traction pack. And that allows us to disconnect the power from the traction pack from everything else. So if that switch is off, nothing happens. If it's on, it allows the power to go to a main contactor. The main contactor is typically controlled by the controller. And when the controller says, hey, it's okay to turn on, then it's going to turn on that main contactor and allow power to go, traction pack voltage to go to the positive input of the controller. If the controller's not on, then that contactor would be off and the power would go any further than that. Okay? Now, let's talk about the DC to DC converter. Told you we would, and we shall. The DC to DC converter simply maintains the charge on the 12 volt battery and shares the 12 volt load. It replicates the alternator found in an internal combustion setup. So you have to keep that 12 volt battery charged. So anytime you turn on the ignition, the DC to DC converter comes on and it takes power from the traction pack, converts that to 13.8 to 14.6 volts, is what you need to charge your 12 volt battery, and that's its purpose. So when you turn on the lights and everything, there's a load on that 12 volt battery. Well, now the DC to DC converter is sharing that load and charging your battery. That way your 12 volt battery is always ready when you turn on your ignition switch or your radio or try to roll down the window or use your remote entry or whatever. So you can see we have the 5 main components, and there's a few little additional components added in. This is, the basics of an EV conversion. You've got a 12 volt system and a traction pack system. Maybe in a future video we'll take a look at our demonstration board, which has an entire conversion on the wall here, and walk through this, walking through an actual physical layout. But for this one, I just wanted to give you some insights to the kind of the very basic introduction to electric vehicle conversion. What is involved, and you can see, very simple. And so if you want to learn more, we have an ebook which is more involved than what I'm doing here, but it's a good introduction to those that are considering doing their own conversion and those that are serious on doing their own conversion. Or a lot of people take the workshops and start their own business, but we offer an online conversion workshop. And all that information is available on our website at ev4unow.com. So, if you have any questions about any of this or any other questions pertaining to conversions, don't leave the comments on the YouTube channel. We don't monitor that very often. It's best to send us an email at info@ev4unow.com. We'd be happy to answer any questions. So, questions, comments, email us. Hope to see you next time. Enjoy the ride.